Hi guys, this is Rod Sidwell. We're going to talk about Activity 5.2, which is steam tables. And there's some new terms in here you might not have seen before. We'll just go through the columns here and look what we see. We've got absolute pressure, PSI-A, that stands for absolute. We've got temperature in degrees F. And we've got the specific volume, in other words, how many cubic feet per pound. And we've got saturated vapor specific volume. Now here's the new one. The enthalpy is a form of energy, and it includes phase changes and chemical bonds. And how we can read this is we could ask question 1. What is the amount of heat energy in BTU per pound contained in water at 60 degrees F? So we go down here to 60 degrees. We go over here to the column that says saturated liquid, which means that it's all liquid. And the answer is 28.06 BTU per pound. Question 2 asks, what is the amount of heat energy in BTU per pound contained in steam at 150 psi, so we'd come down here to 150. Now we see that at 150 pounds, the boiling point is 358.42 degrees Fahrenheit. So all these, we can really read the boiling point here. So if you wanted to know at 101.74 degrees Fahrenheit, the boiling point happens, this is boiling at 1 psi absolute. So as the pressure goes down, the boiling point goes down, and as the pressure goes up, the boiling temperature goes up. So at 150, we just read it off the table. Amount of heat energy contained in steam, as we just go over here to saturated vapor at 150, and there it is right there. Question 3, what is the amount of heat energy in BTU per pound required to convert water to steam? Now, you have to read the top of the question. The boiler is operated at 150 psi, so we have to look at the values for 150 psi. And you can really do this two ways. You could either say, well, I know I'm going from right here to right here, where I have all steam and I've got all water. And so those 2 points on here are right, this guy and this guy here. So here's the amount of energy when it's 100% steam at this temperature. So at 358.42 degrees, if it's 100% liquid, that's how much enthalpy is in there, 330.51. If it's 100% steam, we've got 1194. So I could take 1194 and subtract it, and then I'd find out that I'm getting this number exactly, H of Fg. So that's the enthalpy phase change, and that's the answer to number 3. Number 4, what is the amount of heat energy in BTU per hour required to produce 25,000 pounds per hour steam? So we just found for number 3 that at 150 psi it takes 863.6 BTU per pound to go from water to steam. Now we have to be careful because this is a real example, so we have to ask what are our initial and what are our final conditions, and they tell us that the boiler's at 150, produces 25,000 pounds per hour steam. Calculate the amount of heat energy that's needed to produce the required steam when the feed water temperature is 60 degrees. So we have to, I'll just draw this chart again. So we're starting down here somewhere at 60 degrees. and we're going up here to 358 and some change. So really this has a couple of parts, and you got to add them together. So you got to find how much heat energy do I need to get from 60 to 358. And then you have to add to it the amount of heat energy that you need to boil it. So to get from 60 degrees Fahrenheit, we just use our old answers. H at, I'm just going to call it 60, is equal to, we looked it up here, 28.06. Got enough information, I can go directly from here to here. So I can go straight from here to here. So let's just do that. So I'm just going to write H for 358 for the saturated steam, and we know that that is, let's see, where is it? 1194, right? These are in BTU per pound. And so now I'm going to take 11. So what's the change? 1194, which is the final, minus the initial, minus 28. And that comes out to be 1166. So that's the BTU per pound. Now I need to know how many BTU per hour to get to 25,000 pounds per hour of steam. So I just multiply this by 25,000. So if I take BTU per pound and I multiply by 25,000 pounds, units per hour, units of pounds will go away, and I'll be left with units of BTU per hour. And I get an answer of around 29, we'll call it about 29 million BTU per hour. And that's the size of that's a medium-sized commercial boiler. It might be 10 feet across by 12 feet high, maybe 30 feet long, something like that. So that's relatively common size. Okay, that's it for this one.